Using everything you see here, we're going to build the drone. I've already prepared a few things, and I put braided sleeving over the motor wires. I really like how it looks, and I also shortened the wires. That makes things easier later on. These motors are very powerful. And because the motors are so strong, I decided to go with the Argus Mini 55 amp stack. That can handle around 55 amps per motor, which should be plenty. Before this, I had the original Argus Mini installed, which I think only supports 45 amps. That one died twice already, basically the ESC burned out. So now I'm using a stronger one. It should still fit in terms of size. Now this TPU part here is where you can mount the action camera as well. And on this one, the GPS is hidden underneath. It's up to you whether you want to use GPS or not. For my build, I went with the BZ121. It works pretty well. You can just install it right here, and then this part is already prepared. I also prepared the XT60 connector with braided sleeving as well, so it looks clean. Since I want my Manta to be red, basically red and black, I 3D printed the TPU parts for the arms myself. You can download the file for that on the original website, on the Chinese version, not the European one. The reason is that I want the Manta 3.6 to look like the little brother of my 5-inch Nazgul. Here I've already prepared everything so I can mount the antenna, and also the TPU part from the Manta. I've already plugged in this cable. This is what you use to connect the A unit to the stack. And here I also have something else, but that's up to you. I'm using an ELRS antenna because I like flying ELRS. That is, of course, connected directly to the ELRS receiver. Hopefully you can see it clearly here. You can also prepare this right away, so later on it's easier to work with. Then we basically only need the beeper. That's the light so you can see the AxisFlying logo glowing underneath the drone. And lastly, we of course need the AxisFlying Manta 3.6 frame. This is where the light gets installed. We need these standoffs so the top and bottom sections can be held together. These here are the side camera panels. So, for the onboard camera, this is the top plate. This is the bottom plate. And I think this part here also connects to the top plate. Here we have the different screws. Basically everything you need. And these are the original TPU parts that I won't use because I made mine in red. Next, we basically need the 4 arms, the bottom plate, M3x8 screws, the light, and this part here. We install the light right here. Then you can route the cable through here. Then plug the light in right here. Then you take this part here and put it on top. Then we need 4 of these screws. And that's what it looks like so far. Next, we need to flip the frame over so we can screw in these standoffs here, right here. For that, we'll need the M3X8 screws again. It should look like this at first. Now we take the last two standoffs and press them in from the top. That way, the two TPU parts stay together as well. Next, we need these two camera mounts for the O3A unit. And 4 M3X6 screws. Mount them so that the recessed side faces outward. It should look like this. Now we need the N2X25 screws, the really long ones. We screw them in here for the stack so the ESC and FC can be mounted on top. And that's what it looks like. Something I unfortunately forgot at the beginning, so I loosened these 8 screws here. Where the light goes in, there's also a carbon plate with the AxisFlying logo. You also need to slide that in from the side, like this. This is very important, it sits almost flush right here. Then you can screw everything back together. The next step is optional. I coat my stack beforehand so the drone is somewhat waterproof. That way I can fly in the rain and not have to worry. For example, in winter, if the drone crashes and ends up buried deep in snow. If you want to do this too, there are lots of different coatings. This one here is fluorescent. When you shine a UV light on it, you can clearly see which areas you already coated. I find that really practical. But there are also coatings that work normally without UV. You don't have to use the UV light, but you can. We can coat the underside of the ESC before installing it. We'll do the rest once it's installed. On the flight controller, we can also coat the underside already, and the top side only after we're done soldering. Coating itself isn't really difficult. What's really important is this little hole here. It's probably hard to see on camera. This hole right here. Do not coat over it because this hole is for air pressure. Otherwise your OSD won't show the correct altitude later on. And that would be bad for return to home and things like that. So don't coat this hole. Everything else is fine to coat. For now, just the undersides of the FC and ESC. And that's it. With the connectors, be careful not to apply too thick of a layer here, so it doesn't mess up the contact of the plugs you'll connect later. Check it really well with the light if you use a special coating. You can clearly see where you already coated. Because on the FC I haven't done anything yet, and as you can see here on the FC you don't see any bright blue. It should look something like this. You can also see clearly that there's no coating on that hole, so don't coat right here. Now we need these rubber grommets. You always thread them in so the larger gap is on the bottom. On the ESC it's a bit trickier, but it's the same idea. The larger gap has to be at the bottom. First, thread the smaller gap in from underneath. I usually help myself with a toothpick. Once it's almost through, you can pull it out nicely with tweezers. It should look like this. Next, we'll solder on the capacitor and then the XT60 connector. The important part is the white side goes to negative and the black side goes to positive. Trim it down to roughly this length and then it fits perfectly. Now solder on the two wires as well. And that's what it looks like. What really matters is that white goes to negative and black goes to positive. Alright, now we need to screw in the motors that we already prepared. Important, the TPU parts need to be screwed in at the same time. The screw length you need depends on the motors you're using. The two outer screws need to be longer than the two inner ones because of the TPU part. Now we can take the ESC and mount it with the XT60 cable pointing to the left. That's intentional because on the Manta, the cable routes in from the front through the top plate and then goes back. On most drones it exits at the rear, but the Manta is different. Now we need to solder the motors. At this point, before coating, we should stop for a second and do a quick short test using a smoke stopper. Looks good. Before coating, you can plug this in so no coating gets inside the connector. With this cable, you connect the ESC to the flight controller. When coating the top side of the ESC, you don't really need to worry about anything special. You can coat across the whole surface. Alright, now we can install the prepared O3. This is roughly how it should look. Now we can mount the camera. Later on, it's important that you install it with the DJI logo facing down, like this. Otherwise the camera will be rotated 180 degrees. You need to insert the pads from the inside. Then squeeze the camera in between. And tighten it down with the 4 camera screws. Alright, now we screw this part down from underneath with these 2 screws. And that's what it looks like. These 4 wires are for the ELRS module. And here you have the connector for the O3 air unit. We'll plug that into the SE later. Same with this cable here. We'll plug that into the FC as well. Then you can plug it on top. Now we solder on these 3 wires here. They come out at the bottom, and they're for the light. That part is optional. You can also leave it out. The black wire goes to GND, the white wire goes to LED, and the red wire goes to 5V. Now we solder on the 4 ELRS wires to GND, 5V, R2, and T2. Important, the RX from the ELRS receiver goes to the TX on the flight controller and TX to RX. Now we install the buzzer, also called the beeper. For this we need the M2X5 screws. Now we can solder on these 2 wires to B and 5V. The red wire goes to 5V again. The black wire goes to B. And lastly, we still need to solder on the GPS. Before we coat the top side of the FC again, we'll do one more smoke stopper test. We can hear the beeper working. We can see the blue blinking in the back. That's ELRS, so that's fine too. And here we can also see that the GPS is lit up, so that works as well. Test passed. Now on to the coating. Looks good. Now we just need to install the nuts on the FC screws. It's important that the FC can still move slightly. Now we're at the point where we can put the side panels on. I had to trim them a bit with side cutters because they wouldn't fit. My ESC is a bit bigger than the original, so it needed some clearance. Be careful not to pinch any wires here. Now we need to connect the top plate with this part and screw it down. Now we only need the battery strap. Thread it in carefully so you don't damage the FC solder joints. Then we also need the anti-slip battery pad. We won't put the propellers on yet because we still need to set the motor direction in Betaflight, and we definitely don't want this thing to explode in our face. Now we're in Betaflight, and first we're going to calibrate the accelerometer. For that, the drone needs to sit on a level surface, and then you click Calibrate Accelerometer. It only takes a moment, and then it's calibrated. The arrow has to point forward towards the camera. Now you can rotate the drone and check if it moves the same way as you move it in real life. That should be fine, and for me it looks correct as well. Next, we'll configure the serial receiver VTX and the GPS. On UART 1 we have the VTX, so under peripherals we enable VTX plus MSB DisplayPort. And on UART 2 we have, in my case, the ELS receiver soldered in, so we enable it here. Now we need to enable GPS here. The baud rate, meaning this number, can differ depending on the GPS. If your GPS doesn't work with this value, you'll need to try the other values and see which one works for you. Then hit save and reboot. Now we go to the basic controller configuration. RX lost is when the drone loses connection to the radio and then it beeps. That's why I enabled it. And here, I basically enabled everything except GPS. Because personally this beeping annoys me in this case. But that's personal preference, you have to decide for yourself. We could enable failsafe now since we installed GPS, but there are lots of videos and guides on YouTube for that. If so, let me know in the comments, and I can make a video about it. But for now, I'll set it up so in case of signal loss, it simply cuts the motors and drops out of the sky. Now we go to the receiver tab. If you fly ELRS, it's important to select the Crossfire protocol and choose serial via UART. Now we go to the Modes tab. Of course, this depends on which controller you have. You can plug in the battery, and for example in the receiver tab you can see which AUX channel moves when you press a button. That's how you know which switch is which. Then you configure it to match your radio. Basically, you can set it up exactly like I did, and you'll have the same switch assignments, but it depends on which controller you use. I'm using a Radio Master Zorro. If you also do, you can copy my setup. This way you can make the drone beep whenever you press the button you want or flip a switch. Flip over after crashes when you want to use turtle mode if your drone is upside down. That way you don't have to walk over to it. In this mode, it can flip itself back over. So when you enable it and apply some throttle, you might be able to flip it back over and keep flying. Next, we go to the PID settings. Personally, I always set up 3 different rate profiles. You don't have to do that, you can also use just one. But later on I map them to a 3-position switch, so while flying I can change them and for example use a slower profile or a faster one for freestyle. That's the reason why I use 3. Your rates depend on your preference, so you can set them however you want. I set mine to what you just saw. Now I'm setting up what I mentioned earlier on the 3-position switch, so I can switch between rate profiles while flying. And you have to decide which button or which switch you want to use. Under GPS, it's important to use AxisFlying as the protocol. That should already be selected by default. OSD is personal preference. Set it up the way you like. For example, I use HD, but you can choose something else. It's all down to preference. You can configure it however you want. Now we're in the Motors tab. It's important that you enable motor direction is reversed. On older drones it was different, but that got changed because they found this works better. So make sure it's enabled. You can enable this if your ESC supports it. Motor poles should already be set correctly, and for most drones it's 14. Now we need to remap the motors so the drone knows which motor is which. Make sure the props are not on the drone. Seriously. Otherwise you could hurt yourself. The battery needs to be plugged in now, and then you select the motor that's currently spinning. The camera needs to face forward, just like the arrow. Now we can set the motor rotation direction exactly like you see here. Now the motors are spinning, and if they spin in the wrong direction, you can select that motor and the rotation direction will be reversed. Set it so it matches the diagram at the top.